In the last class, we have discussed about how we can interpret velocity time graph. We also know that what we can conclude from the interpretation of velocity time graph. The first one is the gradient of the line, which is equal to acceleration. Negative gradient indicating that deceleration. Flat section means that the object is moving with constant speed. And if you want to calculate the area under the curve, what you get? You get the total distance traveled or displacement of an object in a given interval of time. Next, for the same graph, they are asking us to calculate the total distance traveled over the 50th second. That means the entire journey from 0 to 50 seconds. We also know that area under speed time graph gives the distance travel. So if you calculate the area under this blue line, then you can calculate the distance traveled by the car from 0 to 50 seconds. This is the key point here. Area under the graph gives distance travel. Now, in order to calculate the total distance travel, we are dividing the graph into 4 sections. A, B, C and D. So A is a triangle, B is a rectangle, C is the sum of triangle and rectangle. We also call it as a trapezium, and D is in the form of a triangle. So calculating the area of a triangle, we know the formula half into base into height. So half times, what is the base here for the section A? It is 10 seconds and the height is here, right? So 15 meter per second. So 10 seconds multiplied by 15 meter per second. Second will get cancelled. 10 into 15, 150. 150 divided by 2, what do you get? 75 meter. So that is the section A distance travel. That is the distance travel from 0 to 10 seconds. Next, for the second part of the journey, you can see that it is in the form of a rectangle. Calculating the area of rectangle is base into height. Area of rectangle is base into height. So base is again 10 seconds and height is 15 meter per second. So 10 into 15, 150 meter. For section B, the total distance travel is 150 meter. And for section C, it is not in the form of a triangle or a rectangle. So it is in the form of a trapezium, or you can calculate the triangle this separately and the rectangle separately. Then you can add these two. So we know the formula for calculating trapezium. Area of trapezium is half into sum of parallel sides into perpendicular distance. So what are the sum of parallel sides here? So sum of parallel sides, this side which is 15 meter per second and this side which is this distance plus this distance. So 25. So here it is 15 and here it is 25. Sum of parallel sides, that means 15 plus 25 into perpendicular distance. What is the perpendicular to this parallel lines? This one, 10 seconds. Half into sum of parallel sides into perpendicular distance. 25 plus 15 gives you 40. 40 into 10 gives 400. 400 divided by 2 gives you what? 200 meter. So see what you get, half into 40 times 10, which gives 400 divided by 2, which gives 200 meter. So this is 3. Again in the last part for D, it is in the form of a triangle. So half into base into height. So what is base here? It is not 10, it is from 30 to 50. So 50 minus 30 gives you what? 20 seconds. And height is from 25 meter per second. Okay. So half into 20 into 25. So you get it as 250 meter. This is equation number 4. We have calculated each section separately. If you want to calculate the total distance traveled from 0 to 50 second is 75 from section A, 150 from section B, 200 plus section C and 250 from section D. Add all, you get it as 675 meter.